Today I want to talk about the practical applications of game theory and whether or not they can be fully applied to real life. But before presenting the primary question, what is game theory? Game theory is the branch of mathematics concerned with the analysis of strategies for dealing with competitive situations where the outcome of a participant's choice of action depends critically on the actions of other participants. Simply, it's the mathematics associated with games and calculating the most optimal move or play for a game. One of the leading mathematicians of the 20th century that greatly contributed to the world of game theory was John Forbes Nash. Born in 1928 in Bluefield, West Virginia, Nash showed signs of mathematical genius at a young age, according to Sylvia Nasar's award-winning biography, A Beautiful Mind. The most important thing that John Nash did was broadening game theory into a combination of both cooperative actions and competitive ones. This made game theory a lot more applicable to real life, since most actions that are done in the political, economic, and social world are both cooperative and competitive. This brings me to my primary question. How applicable is game theory to real-life situations? Although certain parts of real-life interactions are omitted in game theory, overall, game theory can definitely be applied to real-life situations. To prove this, consider this situation. Okay, so Mrs. Travasos and Mr. Keller have been arrested for giving their students way too much homework. However, the police department wants to know who the prime suspect is among the two. So they split Mrs. Travasos and Mr. Keller and interrogate them in different rooms. Now Mrs. Travasos and Mr. Keller both have two options. They can either rat out their partner or choose to remain silent. Let's visualize this in what is called a payoff matrix. There are four possible outcomes in this situation. If both Mrs. Travasos and Mr. Keller stay silent, they both get 1 year in prison. However, if both of them rat the other out, they both get 3 years in prison. If Mrs. Travasos rats Mr. Keller out and Mr. Keller remains silent, Mrs. Travasos is set free, but Mr. Keller gets 10 years in prison. Likewise, if Mr. Keller rats Ms. Travasos out and Mrs. Travasos chooses to remain silent, Mr. Keller is free and Mrs. Travasos gets 10 years in prison. This is known as the prisoner's dilemma. As a prisoner, what is the optimal decision to make? So, the obvious decision to make here is to not confess at all, right? Best outcome for both people. But Nash says otherwise. Think about it from the point of view of one person. Let's look in the mind of Mr. Keller. He's thinking, if I don't confess, there's a 50% chance that we both get only 1 year of prison. That's cool. But if I don't confess and Mrs. Travasos decides to rat me out, that would give me 10 years in prison. Yikes. However, if I were to confess, it's a win-win situation for me. I either get only 3 years in prison if Mrs. Travasos decides to confess, and I get set free if she doesn't confess at all. That's much better. And the same thing is going on inside Mrs. Travasos' head. So the Nash equilibrium, which is a situation in which no participant can benefit by changing their strategy, is if both of the players confess. Although the situation and the results may not be the same, these kinds of interactions can be seen in real life. For example, businesses choosing to invest in other businesses, or countries choosing to sign trade deals with other countries. One common economic application of game theory is a company deciding whether or not to advertise a certain product based on the actions of a competitor. A payoff matrix similar to the prisoner's dilemma can be set up, and once again the Nash equilibrium is if both of the companies choose to advertise. Essentially, anything with choices and gains can be rationally proved with principles of game theory using similar payoff matrices, from something as complicated as political and economic decisions to something as trivial as a game of poker. As more factors are introduced, these payoff matrices become more complicated. However, there are dissenters that say otherwise. Some researchers from the University of Hamburg did some research on inmates to see what would happen in a real-life simulation of the prisoner's dilemma. However, what they found was that inmates are far more cooperative, meaning they don't rat each other out in real life. In fact, the prisoners stay quiet 56% of the time. The researchers generalized this finding to say that the concepts of Nash equilibrium are math and nothing more, and cannot be applied to real life. It is completely true that these mathematical models do not necessarily take into account things such as feelings. For example, what if the two prisoners hated or loved each other? However, game theory models are priceless in the corporate and political world, where feelings are not generally involved. As you can see, game theory can be applied to many real-life situations. Although it may rationalize certain situations much farther than they are in real life, it still helps us understand and predict many political, social, and economic interactions. Thanks for watching.